Okay, the next talk is Wireless Power Transfer by David Emmert. Give him a warm applause.
Everybody, hello. This is my geek approach to reproduce exotic technology, which is Tesla's magnifying transmitter, and that is a wireless power device. The beginning was using some internet information, reading the patents, original texts like that one, and the power transfer was something I will show. Just a second. That was the original patent that actually was produced by Tesla, and in this text it was not easy to understand how is it done, because the language was used very archaically. In that times the technology like electronics were not developed, so he used some analogs from mechanics and similar terms to describe electrical terms which he used, and the logic that is done to produce the wireless power transfer device. By collecting the information, afterwards I get some picture how should it work. So I started to build the prototype of based on my understanding and some calculations. I will show you in this course what I have understood from the principles. How does it work? It's my version. Probably it works something similar, or it works completely different than mine, but this is an approach based on known knowledge, based on known software and known calculations, and many of the effects which are at the first time unexpected or strange could be explained using the software and the calculation, but I guess not all. This technology is, just a second. There is something called Tesla magnifying transmitter. It is a device that is different than Tesla's transformer, in a sense that is somehow simpler, and it works better for the wireless power transfer. I would show you, if I can see somewhere, the Tesla's transformer. I must look at that. Yes, this is the Tesla's transformer that we usually know. It has primary coil that is thick wire down there, and it has the resonator. This is a coil with many thinner wire turns, and there is a top load capacitor up there. This device was used by Tesla at his early days, about until 1895, when he invented the magnifying transmitter. Now, in the early days, that was an experiment that Tesla demonstrated at New York, which he could power wirelessly some kind of fluorescent lamps, and the lamps everywhere in the room stayed light. All the lamps were powered by some device similar to that. Now, I would like to begin, just a second. I have another things to see. So the wireless tower is his next. I will show it again. Tesla's wireless tower was never completed. It was the biggest device ever built, and we believe that was the that was the future supposed to be magnifying transmitter. My version of how should it be completed is to wind the wire around this tower. And when this tower was built, Tesla in his, I was reading some texts which are probably from the internet. I cannot confirm their if they are really true, but Tesla wanted for this tower to be reversed. So it should be white at the top and thin at the bottom, something like ice cream. But this stuff wouldn't handle the statics. I have done the calculation with the reverse geometry, and it should work better. For the same material used, you can get more power from such device. So I have replicated something like that in my experiment, but first time, for the first we need to know how does it work in his essence, and then try to build some prototype. So well, I started with, oh yes, I forgot something. The main idea of this tower was to transfer energy in long distance. This is not a mobile device. This is something that it actually is only effective when it is big and when the power transferred by this unit is large. Such tower, Tesla said that could transmit 7 megawatts of power, but from the calculation, it goes that if you have a dry day, and so the conductivity is low of the air, it could accept 180 megawatts, what was approximate whole production at the Niagara Springs power plant. So something like that. This device works and uses Earth as a planet and as a part of the antenna. So the Earth itself is how can I say, is taking a part in the transmission in a way that this antenna is non-symmetrical. One part of the antenna is that, and so coil is down there, and the Earth and the ground below is second part of the antenna. So it's a transmission device that is done on the planetary level. That is the range. So any range on the planet should be accessible with such device. So I started with the texts, original ones. I think something like that. And these texts we will skip something. This is a mechanical analogy when Tesla explains what's the difference between ordinary power transfer with 2 wires and the other thing when only one wire, in this term this wire is the Earth as a planet, is used as power transmission. So in the alternating current circuit that has electrical schema up there, here is a generator, and there are 2 wires, and there is some kind of lamp that uses this energy. Mechanical analogy of this transfer is a piston and the water pipes around here. So piston goes up and down. This is our alternating current, and pushes the water alternatively up here or back there. And this is a thin tube that receives the energy. So the second analogy is his wireless transfer device that has ground connected to one part of one terminal of the generator, and the second terminal is connected to the capacitor in the air. This is this ball that you have seen on the magnifier. And the piston goes up and down like that, gets energy to the consumer, and here is a let's say some kind of a balloon that is that can be filled with water and emptied when the piston goes back. I have one animation to make it better to see. I will orient that like this. So computer will do it now. What this device does, let me stop a little bit. Imagine this is a capacitor, and size of this ball is actually size of the pumped balloon up there. So what generator does, it pushes the charges, electrical charges, or water in our sense, up here and back there. And it does it in an alternative current fashion, so it goes up and down. This is our AC. This device would not be suitable for wireless energy transfer because of the charges will be plus on upper ball and the minus on the down ball. And if you see these charges from long distance, you will actually see neutral charge. But the idea is that the ground was used. So if this charge back there was below the sea level or in the ground, then the observer above the ground will only see charge going plus from nowhere and then going down to zero and then again to the minus. This was idea of how to separate somehow normal dipole radiation from something else that was used here. And how could it be with the electrical device is by using the resonance. And for this we have some more calculation up here. Wait a minute. This is something called quarter wave resonance. So imagine our coil, or the bottom coil of winding of the magnifier of this antenna is in the z-axis above, and the dimension of this is actually electrical field created by that. So we want to send a wave through this. So wave can go up and reflect down from the capacitor back, and something which is done is something like that. But there are two waves, up and down. We actually would have these up and down waves go immediately at the same time. So they add one to each other, and what actually happens is sum of two waves, and then we go standing wave inside of the coil. And the coil resonates as one. So we get something like that. Every part of the coil is synchronized when it is done right. That is what is written in the text of Tesla's article from 1919. Okay, so I had some information about the principle of working, and now I started to make a device, and I had I needed some more calculations. I will show you to you my simulation to more, let's say, picture, get a more in better picture to the difference between normal antenna and what we want to use with this device in terms of the field in the space. This is a simulation from antenna design software that is here. This one above, this one to the left, is normal dipole antenna. It's schematics. The generator is connected to the middle. I want to show you how normal radio works now. Alternating current is pushed at this point to the plus and minus terminal to the antenna, and color of this rod of the antenna indicates the current flowing through it. So at the end of the antenna, current is almost zero. We can this to the legend, it's nearly blue or violet. And when it is red, the current is maximum. Analogy in the space is the electric field. This is the electric field. The direction of these marks are where the electric field points to, and the color is magnitude of the field. And we can have the animation. So when this works, when this antenna is powered with alternating current, some kind of wave goes away from the antenna. This is only electric field shown. I can show you here also the magnetic field. So both of these fields, if you can notice, are perpendicular to each one. So there is a right angle between them. This is normal electromagnetic radiation. It consists from the electric and magnetic field, which are at 90 degrees in the space one to each other, and as well 90 degrees to the direction when it propagates. We will stop this one and look at the Tesla's simulation of the Tesla tower. What does it produce there? Okay, this is Tesla tower, and this is electric field from his tower. I can explain what is that. Tesla in this tower, in their building, it is not shown on the picture, has ground connection about 50 meters below the ground level. It needs to connect to the earth. So this is some kind of a network. It's not the same like Tesla did. So this network was somewhere here above, but I think it doesn't matter to this simulation. What this device produces, we can see that with the animation. So actually no wave is traveling in the space like before. It just creates the electric field that is stronger in the plus and stronger, of course, symmetrically in the minus, identically in all around here. Here we can see something like spherical symmetry, not complete, but similar to, because all of these field lines are on the identical place. Yes? You want to see the pointing vector? Okay, we can do it. Yes. Okay. Okay, pointing vector is, so it's not easy to imagine, but pointing vector is somehow circulating all around this device. Actually, pointing vector is nowhere, because electrical fields and the magnetical are nearly in the line with each other. So pointing vector is in the first, as you can see, violet. This is near zero. Okay, not always, but somewhere here it has some. This device radiates a little bit. It's not possible to make perfect geometry of this device so that you can have only the electric field, but magnitude of the electric field is much higher than the magnetic. Okay. Okay, this is exactly what I want to show you, but I must first show you this, and then look at the magnetic field. I will stop the electric. So magnetic field as well is actually as well in the violet range. So it's near zero, except in the middle of this, of course, coil, which has some magnetic field. Now I have some other. I would show you at the first some kind of a device that I designed, the same like that, and then I will show you a simulation of two devices connected to each other only with the ground that actually transfer power. Okay, we don't have radiation here. What happens is the ground. We should not forget that we have one common connector, and that is planet Earth. So it is used as a charge capacitor conductively. Earth as a soil has conductance, has capacity, and some inductivity as a medium. This is used as power transfer. Some wave is traveling through the Earth, and that goes seen on the other place. And the other thing is that these charges to connect electrically to each other. So there is some kind of static electricity, static. It has some frequency, and it is not static in a time sense, but it has similar behavior like a static electricity, which I will show you at the video from my experiment, that this device actually works. So here I have my device that is in the logic similar to that. I thought about this. So the tower is reversed. I can do it with small models. And the electric field is somehow similar with that one. We can check this out with the animation. On the below, there is some kind of distortion, but on the top, we have practically the same. The geometry, I don't need to show the pointing vector, is the same like before or similar. And when we have two of these devices, I must stop because we have stop animation because we will load the computer now. It is difficult to calculate this to the computer. Okay, that's one. We have, I made simulation of two of my devices. They are tuned to the resonance at the same frequency, and we will get some animation. So let's see, just a second. I'm not on the right screen, I guess. Just a minute. Okay, this one. Okay, animation here. Okay, that's the one. So this is how do they work when they do power transfer one to each other. Look at the current through the Earth. It's not zero, but it's close to. So the Earth is not used as a true conductor. The resistance of the Earth will not make much losses to this transfer of the energy. Look at the transmitter and the currents. It has a little bit yellowish, oranges, so the current is somewhere in this range. In the receiver, current is even stronger. And how do they connect? They connect to each other to the space because the charge is here and charge is there, so the repulsive force. At each time, they are pushed from the Earth above, so each charge is repulsed to each when they see them above the Earth, and then again at the same time push the charge back. So the current goes down and down here at the same time. This is how it works when it works in the normal mode. It can work in the other mode when there is a plus here and minus there, but this is only one-to-one connection. So this connection is meant to be to have one transmitter and many receivers, and the other one works better, but it is used only for one transmitter and one receiver. It cannot be three of them. And my device was done from the plastic bottles. I have pictures of that somewhere above. Wait a minute. My device. Experiment. That was actually 6 years ago. I started with a plastic bottle like that, and then I made this wound coil here and aluminum foil up there. So I first connected that to the scope and the signal generator in order to find the resonance. Resonance was found about 1 megahertz in this prototype. When this is at resonance, driven by 10 volts sine wave, 10 volts, 10 milliampere, nothing more, it can light this. This is not touched to the top of the aluminum foil. It can even drive the neon lamp to light like that. So in the dark, neon lamp can be inside. It's so strong electric field. This one it creates so much electric field that you don't need to connect it to any place around. It even doesn't need any metallic contacts. You can have only neon lamp with fluorescent coating and the gas inside. This is enough to be driven by this device. that one, and actual transfer of the energy is like that. So this one is transmitter, and this is the LED diodes connected to the ground at the receiver, so they light. That was my first experiment when I observed the effect. These LED diodes can light at, of course, smaller intensity at the room 10 meters away. I have another improved type of geometry like that. This is the second experiment. This one can as well do the same things and drive the... these things now drive very greater. Here is the receiver that has LED connected to the ground. An LED works like that. And as well, the receiver itself creates some kind of electric field. Is the same that you have seen at the simulation. Both transmitter and receiver has some electric field. I have a video, but just a second. Video is on the other application. Wait a minute, I must prepare a place when to stop that. Okay. So this is me at here it is. Just a second. I must. Huh? Okay. This is when you can light your face probe away from that. Okay, we can go to the receiver. It's down there. So we will see for the at the beginning, what does it if we disconnect the ground? These are LEDs, and I first check how much the field do we have at the receiver. Not much. This neon don't, but this one does. So it has some weaker effect, but it has some. Okay, you can see, I guess. And that is LED. We will like that, okay? And we can connect the ground. I will touch the ground myself, and LEDs will light a little, but it will light. Watch me touching the ground, and LED will slowly glow. It's difficult to see, but you know, ground is better when, but okay, some objects like people or chairs or something can as well serve as some kind of a ground with a weaker result. So I think this is from my experiment. I have some more pictures about how does it work when at my third experiment. Let me check. Somewhere is here, I think. All right. Okay, this is in our club in Hack Lab. This is both of them are connected to the radiator. So this is an oscillator with a transmitter box. The transmitter lamps can light in closeness of that, and there is a receiver. So the normal fluorescent tube is inside, and it lights. That is from my experiment. I know there is one experiment as well, even tonight. People will make a musical Tesla coil in front of the BCC. So some more experiment can be seen as well today, but not the energy transfer, because they have only one coil, but probably if you have another coil, you should receive some energy too. Do you have maybe some questions? Of course. Give what? Aha. Okay, the question was, I have not questioned the man said, but only the answers. Okay, if
Yes.
some...
Yes, the thing is for the following. Those experiments are circulating the internet for about 20 years. And actually I'm using it with my students in the physics class to give them some basic understanding of energy transmission. And this is a classical example of how people sometimes get confused how things work. The interesting thing is not the energy is not transmitted between the both coils in the free space. Actually, the energy is transferred by the common ground, or to be exact, the electrical field traversing along the ground. If you cut the wire, or if you're using the real Earth, it won't work because the both coils are no longer in resonance. I asked you about the Poynting vector because if you would have expanded the simulation to contain the whole Earth and the complete connection, then you would have seen that there is a Poynting vector along the common ground, and the energy is transferred by the ground or the wire. So it's not really wireless transfer. You have just replaced two wires by a single wire, where energy is pushed between both coils forth and back. And if you take out some energy from one of the coils, the energy will replenish from the other coil, and there is always a push and back between both coils and the wire, which creates the energy transfer. It's nothing completely new. It has been long known. It can be perfectly calculated in Maxwell equations. So I have to give you a small sort of damper here, because it's really known. You can fully describe it in the classical theory.
I have tried with the Earth here, and it works. Normal Earth, not only normal Earth, you can have objects like chairs or tables that you can connect instead of the ground, and it will work. So this can be explained as well, but I mean, cutting the wire is not enough to stop this transfer. You know, I tried that. This is no problem, but only the results are weaker, and it doesn't work so bright, but it works at some level, you know. This, I guess, this is not only connecting to the wire, because I have really connected to the massive ground. This central heating device is actually even grounded. It goes to all the house. It could be simulated to the Earth. Well, Tesla, in his original document, said that the frequency that I'm using, about 1 megahertz or somewhere below, is not good for energy transfer through the Earth, because Earth has some properties. And there are in his text, I can even show this, I have on that one, that is a real frequency range that Earth will be really used without losses, about 10 to 25 or 50 kilohertz. Above of that, the losses are too large and significant to the power transfer. In that case, we would have to build greater or bigger device to achieve 25 kilohertz. To my calculation, I need about 10 meters of this bottle. This one would be in the range that Earth will be nearly insignificantly losing our power. So I think I can even go to original text and do it somewhere here. Let's see.
Sorry to say that, but that was not Tesla's invention. Tesla had not one single invention at all. He was a strawman. This was one strawman that found the Reichenbach. Yes, of course. The problem is the main understanding problem is.
If you have a question, please ask a microphone. There's one in the middle, and the other one is with me. So if people can please keep some space free.
The main problem is I made this mistake too. We are talking about electrical energy, and this wireless transmission is not planned for electrical energy. Count Reichenbach had the discovery of Schauberger named the atomic energy of the first order, called the odd energy. The odyllic energy has nothing in common with electrical energy. Yes, that's true, that's no joke. The main concept of the Tower of Wardenclyffe are the 90-meter depth Earth anchors. The Earth anchors are better known as the Earth batteries. Nathan Stubblefield had something similar, or Edgar Cayce had copied that concept. They are cooled down by the liquid air, and the odyllic energy is exaggerated by the Tesla coil. The Tesla coil and the capacitors are producing electric energy. That's right, but the electric energy is not the energy that is transmitted. The energy form is just needed to generate the odyllic energy, and that is transmitted wireless and can demodulate it at the point into electric energy again. The concept by Ryszkowski, another one researcher who had copied Reichenbach ideas, calls this energy form etheroid, the etheroid energy. He had similar concepts of that. Tesla was a high-rank Freemason from the 33 degrees, yes. And not even that, he was from a 99er, he was from a 99er society. The main time Tesla joined the Virtual Geographic League. This was Tesla's baby. His main sponsor was Howard Hughes, called the Aviator. And even if the laughers here around thinks that is funny, I got Tesla's legacy, and I know that very well. It's no problem. Next year we can make a photo session and I show what Tesla had really done. And this is not funny. These pictures are real.
All right, I think I only viewed Tesla in terms of what I can go and reach from the internet. So I collected only the available information normally, publicly, and I made the replication of the experiment that works. I guess probably some of this knowledge should have been known somewhere before, and these types of I cannot speak about different types of energy because I don't know, but that could be some implication. Then this thing doesn't use normal laws of physics that we are accustomed to use here. Tesla speaks about speeds greater than light. And it is about, even on display, it takes about 800,000 kilometers per second. This is superluminal transfer. And I have done some calculation about the refraction index and the symmetry of the fields, which can lead to explain us to that. But okay, this is just mathematical explanation of mine. It doesn't...
Sorry, but I think this is a typical example of the internet produces more nonsense than you can fight against if you are a physicist or a radio amateur, and I'm both. So I think the misguiding thing is that you only think that radio waves are waves which are transmitting, but in the near field you have also other things like quadrupole and octupole waves, which are completely included in the multiple development of the Maxwell equations. And you can see this effect in on any big radio transmitter in a few hundred meters. So if you go to one of these stations and you see it, and it has nothing to do with electric currents through the ground. The only thing why you need a ground is because you extend a ground plane antenna by mirroring the electric charge in a good ground, and then you have a dipole antenna. And that's the only thing, and then you can apply the dipole approach. The other thing, I would go to a normal library, go for a good textbook like Maxwell's Classical Electrodynamics, read the first chapters, or would go to a friend who is a radio amateur and let him explain it. But this has nothing to do with all this esoteric stuff. This is
No,
This is pure nonsense.
no, it's not esoteric. I just wanted to show you that this near field that you are talking about is not only in the vicinity of the antenna, but surrounds in all the space if you use a correct antenna. So this one is a resonant antenna, and it can drive charge above and below to the ground. And this thing works. If you make, if you do it works better than normal. What you speak about dipole antenna. Dipole antenna has inverse square falling of the received energy. And in this device, you can have a linear one to the distance dependence on what you can receive. So it works a little bit better than dipole antenna, but okay, if you don't use right frequency, you cannot reach much more. It falls down, but it falls slower than a dipole antenna that is used in a normal transmitter. Because these near fields, because of the geometry of the antenna and the fields, are extended at the longer range. I think that would be the explanation of that. I'm not talking about anything new, because this is 100 years old. I'm only talking about the technology that is still not in use and could be in that sense.
Can you please show the simulation of your two devices with a pointing
Yes.
vector?
It's difficult to see because the pointing vector is small. This program is not easy. Okay. Program doesn't work this. This is difficult to, there are bugs in the program, so we cannot really see that. In this drawing there are too many, this computer is overloaded with a pointing vector. So pointing vector is something like that, it's nonsense. The software doesn't, it's out of the capability of this software. I think computer will crash soon. Any other question?
Yep. You said that you are more or less complaining that this energy transfer technology is not used, but would it be safe to use it? People are complaining about, already complaining about safety of high voltage power lines, but what about something which transmits power wirelessly and all over space? I mean, if some aircraft goes through the field, what happens?
No, there is no problem with that, but in the safety, yes, there are some problems. This thing, as you can see, before turns in the hand neon lights, neon tubes, it creates a large amount of electric fields. So the electric fields are strong, and this is probably not healthy. It could be much above the state regulations of how can I say, irradiation of the persons to the electric fields. Especially if device works on a real power like kilowatts or megawatts. So you are not supposed to be close to this device, but somewhere away from, and driven by, and energy should be transmitted by normal wire. In the house, nothing will change dramatically, but the distribution of the energy would not need so many wires if that was used. So this is a good question, in fact. And
we have seen...
on the airplane, there is no problem. There is no problem to nothing that doesn't resonate, and especially doesn't have a ground. So airplane has no ground, and he can receive nothing from that. But if somebody has ground, he is still not antenna, because things are very difficult to get into the resonance. You should be about below 1% in the frequency range in order to get correct transfer. This is really difficult to tune and difficult to obtain resonant condition. Without resonance, all the things behave normal and you cannot see any other effects of the energy flowing anywhere before you get correct receiver.
We have seen a computer on one of these images, and I want to ask if there is any disturbances at the machines when you use that energy.
Yes, computer not, because his computer is in a casing which is metal, but I have one Thomson wireless router. It gets constantly reset and rebooted while the device is operated. So there are some. Yes, there are some problems with the devices.
Over here.
Yeah.
My question is about the movie. You showed, I think it was the second movie. You disconnected the wire, which was the ground.
Yeah.
You touched it on both ends, and the LED was not as bright as before. So,
Yeah.
So you're saying the LED is getting the power to the air? Is
Yes.
that correct?
Yes, of course.
So if you increased what's it called, the resistance by putting your body where before there was a copper
Yes.
coil, a copper wire,
Yeah.
and it goes down. Why does it go down so much? I mean, that makes no sense to me if what you said is true. That
The only thing what actually you need from the ground is need something bigger, significantly bigger than the top load capacitor here. So I am bigger as a body than the top load capacitor. So capacity of me is larger than the capacity of top of the antenna. So we have some kind of asymmetry in this sense, and therefore I work as some kind of a ground. As well, I need to lay down in order to get the better effect, because I am shielding the field when I stand, when I am higher than the antenna in the video. So if I was leaning down and touching the LED, there would be brighter effect, but okay. It behaves like that. Okay. Do we have any more questions? Yes?
The experiment seems to me very similar to radio transmission. You can also have, when you have an antenna and you put a bulb to it, she also lights.
Yes?
Okay. It seems to me very similar to a radio transmission. When you put a bulb in the near of an antenna, she also lights.
Yes, that's okay.
Is it the same effect?
Yes, there's a same effect. All types of radios, AMs and low frequency radios with large antenna, and when antenna was driving partially like a capacitor and not like a quarter wave resonance line, is the same effect like that. That is as well the same, and you could build some receivers in that sense. Only this thing is optimized to receive the energy. Radio is optimized to transmit information. So we have in the essence of the idea that we remotely power something. That was our geometry of the antenna, driving circuit, etc.
Thank you.
Okay.
Could you please not walk in front of the cameras, please?
I think, we have more time.
10 minutes left.
Okay, I think we have no time more, so you can meet me afterwards and... I forgot. We have some 10 minutes additionally, so if more of you would like to ask something.
Hello. I
Okay,
have a question. I have seen on the internet about here.
Okay.
I have seen on the internet there is a project or a company called Witricity in the States working on transferring electricity wirelessly. Have you heard about this project? Is it somehow related?
I haven't heard about the project. Well, it could be somehow related, but I don't know, because I haven't seen it. I should look at that. If the antennas are similar like Tesla coils, then yes, it's related. The other way of wireless transmission is using the magnetic field, and this is the short-range transmission. Magnetic field should be curves that are close to itself, so you can have some kind of portability, because you don't need ground. But this is an advantage of such devices, but disadvantage would be the range. So maybe this company would probably do with the magnetic field for consumer, if it is for consumer electronics like mobile phones and, I don't know, monitors. I have heard that Sony is implementing magnetic monitor powered by the some kind of a flat spiral coil similar to Tesla's pancake. That could probably be in this slide. But I don't know. I should check internet for this component.
The name is Witricity. I think there's a TED talk on the internet.
Aha, okay, I will check that. So we can get in touch later and discuss. More question.
Sorry. Have you tried putting that, it's here, the guy in the red thing, yellow thing. Have you tried putting that in a scientific context, like asking people who are working in this? I mean, not just researching internet and reading Wikipedia. I know we all love it, but it's not always serious. And like really getting this into science, because we had a few people standing up here who really at least seem to know about physics. I don't, but.
Well, usually they won't accept it, but I think this is because they haven't done anything with these real experiments, haven't tried it. So they are thinking something like they have been taught in the school or in the faculty. And one of the common error was, if we are pushing the current here, we should get some magnetic fields similar to that current, so we will have dipole radiation, etc., etc. But yes, if we not are using the resonance, in quarter wave resonance, if you have seen this, this thing getting bigger and smaller, some kind of different kind of geometry of the wave in the space is created. And this is not the same. So resonance is something like division by zero in that scientific sense, so they stop thinking when they get resonance. Resonance is even not used in many of power devices. Is actually tried to be avoided. For example, if you have a power plant and generator, you want to avoid resonance because these units are not designed to sustain it. It will burn or break electrically or mechanically or somehow. So the resonance conditions can exist, but it will be skipped in a quick time. There are some kind of processing and stuff to avoid it. That is, you know, this technology is not widely used, and because we don't have enough knowledge how does it behave, we think what we have already seen and try to map our normal knowledge to this. And I can assure you that this device works very different than expected when you try to measure the phase, the frequency and the load of the receiver and transmitter when you are trying to load it. The interesting thing is more you load with the receivers, less the driving energy is needed for that. But this is still not a free energy device in the sense that energy goes out from nothing, but just the space around the transmitter is receiving much more energy when there are no real receivers like that built around. And I said in my paper, could this be true free energy device? I don't know, probably yes. If there is some natural source of the oscillating electric field, we can only build the receiver and get some energy from the receiver. This is what maybe is about your question. But yes, the scientific community usually doesn't accept many of that, but the simulation is okay. Simulation works on the Maxwell equations. This is nothing wrong with that. You know, if simulation shows the reception of the energy, and the simulation and the experiment are very in accordance. So if the simulator says this is going to resonate in, I don't know, 700 kilohertz, when you build your device, you get 705 or something like that. It's really good simulation, and the simulated effects are correct. So this is all done with the normal physics. They should accept it, but you know, it's just a way of thinking. People usually want to think about simplifying device. They never account Earth as a planet or soil as something that could participate in the transmission. They think like everything is away in space, and we have only these two and nothing else from that. The simulation program takes account of the Earth. So everything which is below this Y level is Earth, and it has properties different than the air above. Any more questions?
Yes. Did you bring your experimental hardware with you? So
No, the experiment was not brought, but probably we will try to do something at the workshop if the people from CCC manage to buy wires and the forms like that. I will try to build something from that to observe the effect, to get the LED light as well. I cannot promise that everything will be in place, but we will try something.
Okay, we have time.
In Zagreb, you can go to our club, Mama, and we will show you your experiment as long as you want.
Okay, we have time for one last question.
Mm-hmm. Okay, any more?
Just one person going to the mic.
Uh-huh.
So yeah, for me, I don't care really how it works exactly. For me, I think two things are really important. One is what is the efficiency in percent? So it's nothing completely new to transmit 1% of energy through a meter or so.
Mm-hmm. Yes.
So I care for the efficiency, I care for the distance, and I ask why didn't you bring yours to show it here?
Okay, I went with a plane, and this kind of baggage like a high voltage generator and stuff will probably not be accepted. One of guys have lost the screwdriver in order to probably attack the pilot or something. So that is why I haven't brought the experiment, but there is no problem with the experiment. Really, I'm not the only one doing that. Efficiency in this one, because I have heating in the wire gets heated and it gets about half of the power converted to heat. We cannot do anything to that. And we have second half. From the second half, there is 1/4 radiated as the normal radio wave. So this is as well lost. So we have 25%, only 25% efficiency in the air in the ground of this device. We have 1/4 of the energy transmitted over, and this device as well does the same one again. So it's 1/16 of the energy that goes to LED from the transmitter. This is because the examples are small. It's only for you observing the effect. When we are going bigger and get this device high about 10 meters, if we can trust the Tesla's papers, we can have Earth in much better condition, and then the distance is no problem. It should be any distance on Earth. It should be about 150 kilowatts transmitted of the energy. and no problem with the distance. Of course, no problem with the losses. Losses go down as approximately as the square of dimension, because wire can get thicker and frequency gets lower and skin effect is less. So bigger devices are okay with everything.
Okay, if there will be a workshop, check the wiki. Let's give a warm applause for Davor Amart.